numbers 13 through 18, I'm told to match the piecewise function with its graph. I'm going to first analyze number 13 and try to determine which of the following 6 graphs represents this piecewise function. I'm told that f of x is equal to x minus 4 for all those values where x is less than or equal to 1. And f of x is equal to 3x for all those values where x is greater than 1. Since 1 seems to be my breaking point between the two pieces of the function, I'm going to look for a graph which breaks at x equals 1. I can eliminate b, looks like it breaks at 0. I can eliminate c, it appears to break at -1. I can eliminate f as well because it appears to break at 0. So I've narrowed it down to A, D, and E as the 3 graphs that have a break at x equals 1. Going a little further, I'll notice that in my graph, in my function, all those values that have an input of x is less than or equal to 1 will have an output of x minus 4. X minus 4 seems to have a slope of 1 and a y-intercept of -4. So for all those values for which x is less than or equal to 1, I'm looking for an upward sloping graph who meets the y-intercept at -4. I can definitely eliminate A, as the values less than or equal to 1 do not appear to have an upward sloping graph, but rather a downward sloping graph. And I've narrowed it down to D and E. Again, looking for x minus 4, a graph in which the slope is 1 and the y-intercept is -4, and comparing the two graphs, D and E, I'm just looking at the piece where x is less than or equal to 1. In letter E, this appears to hold true. All those values where x is less than or equal to 1 appear to have a positive upward sloping graph whose y-intercept is -4. Just to be sure, we want to check the other piece in the piecewise function. In E, for all values in which x is greater than 1, it does appear to have a graph whose slope is 3 and whose y-intercept, which is unwritten, is 0.